So good day guys, my name is Nico Madera from the ECE23 and I'm here to present to you what is DPCM. What is DPCM? Differential pulse code modulation. Differential pulse code modulation is a signal encoder that uses the baseline of pulse code modulation but adds some functionalities based on the prediction of the samples of the signal. The input can be analog signal or digital signal. The above figure shows a continuing time signal x times t denoted by a dotted line. The signal is sampled by flat tap sampling at interval ts, 2ts, 3ts, and ts. The sampling frequency is selected to be higher than Nyquist rate. The samples are encoded by using 3-bit 7 levels PCM. The samples are quantized to be to the nearest digital level as shown by small circles in the above figure. The encoded binary value of each sample is written on the top of the samples. Just observe the above figure at the samples taken at 4ts, 5ts, and 6ts are encoded to the same value of 110. The information can be carried only by one sample value, but 3 samples are carrying the same information means redundant. The principles of differential pulse code modulation. If the redundancy is reduced, then the overall byte rate will decrease and the number of bytes required to transmit one sample will also reduce. This type of digital pulse modulation technique is called differential pulse code modulation. The DPCM works on the principle of prediction. The value of the present samples is predicted from the value sample. The prediction may not be exact, but it is very close to the actual sample. This is the DPCM transmitter. The below figure shows the DPCM transmitter. The transmitter consists of a comparator, quantizer, prediction filter, and an encoder. The sample signal is denoted by x times nts, and the predicted signal is indicated by x raised to nts. The comparator finds out the difference between the actual sample value x nts and the predicted value x nts. This is called a signal error and it is denoted as ENTS. ENTS equals to x nts minus x raised to nts. The quantized error signal EQ-NTS is very small and can be encoded by small number of bits. Thus, the number of bits per sample is reduced in DPCM. The quantizer output will be written as EQ-NTS equals to E-NTS plus Q-NTS, and we get XQ-NTS equals to X times NTS plus X times NTS. Therefore, the quantized version of the signal XQ times NTS is the sum of original sample value and quantized error QNTS. Output of the prediction filter does not depend on its characteristics. The DPCM receiver. In the absenteeism of noise, the encoded receiver input will be the same as the encoded transmitter output. The predictor undertakes a value based on the previous output. The input given to the decoder is processed and that output is summed up with the output of the predictor to obtain better output. That means her first of all the decoder will reconstruct the quantized form of the original signal. Therefore, the signal at the receiver differs from the actual signal by quantization error QNTS, which is introduced permanently in the reconstructed signal. Here is the difference of the PCM and DPCM. Its parameters, number of bits, levels, step size, bit redundant, quantization error, and distortion, the bandwidth of the transmission channel, 6. The feedback complexity of notation, signal noise ratio or SNR. The application of DPCM. The DPCM technique mainly uses speech, image, audio, signal compensation, compression. The DPCM conducted the signals with the correlation between successive samples leads to good compression ratios. In images, there is a correlation between the neighboring pixels in radio signals. The correlation is between the same pixels and consecutive frames and inside frames, which is the same as correlation inside the image. This method is suitable for real-time application to understand the efficiency of this method of medical compression and the real-time application of medical imaging such as telemedicine and online diagnosis. Therefore, it can be efficient for lossless compression and implementation for lossless and near lossless medical image compression. Summary: differential pulse code modulation is a technique of analog to digital signal conversion. This technique samples the analog signals and then quantizes the difference between the sampled value and its predicted value, then encodes the signal to form a digital value.